This is the fourth video in the series to predict the relative acidic strength of two or more acids based on the stability of their conjugate base. Now, to predict the stability of the conjugate base, we discussed various factors. In the first video, we discussed electronegativity. Second, we discussed resonance. Third, we discussed inductive effect. And the fourth, I'm going to reveal that. But let's pose a problem and see how it develops. Like if I have a molecule like CH3, CH2, C triple bond CH, and I treat it with the base. Now there are two possibilities. The base can take up this proton, which may lead to CH3, CH2, C triple bond C negative charge. Or the other possibility is that the base takes up any of the protons which is connected to the sp3 hybridized carbon. So I think you might be aware of that this is sp hybridized carbon, okay, while these are sp3, sp3, sp. Fine. So with this, the product we are going to get is CH2 negative, CH2, C triple bond CH. Now, which of them is more, the equilibrium, in which of them the equilibrium is more towards the product side, or which proton is more acidic? That is the question. Is this, which is in the purple color, or is it the one in the yellow? Okay, so that is the question, and that can be answered if we look into the state of hybridization of the carbons bearing those protons or hydrogens. So in this case, if I look at this anion, okay, so if I look at this, the negative charge is present on the carbon. Just a moment. The negative charge is present on the carbon bearing the which is sp hybridized. So this carbon is sp hybridized, while here the negative charge is present on the carbon which is sp3 hybridized. So if I look at the various factors, so both of them, the negative charge is present on carbon. So electronegativity cannot help us in predicting which equilibrium is more towards the right hand side. Resonance it doesn't show, so that can not be helpful. Inductive effect will not be helpful in this case. So the factor which is actually going to help us in predicting which proton would be more acidic of the purple and the yellow one, that is the state of hybridization of the carbon bearing the negative charge. So here it is sp hybridized carbon, here it is sp3. And we know that for sp hybridized carbon, there is 50% s character in that orbital. And for sp3, it would be 1/4. So it is quite less. Okay. So it is 25% s character. And we know that greater the s character, the more would be like the spherical symmetry of that orbital, and more the electrons would be attracted towards the nucleus, or that, which means that it would have greater electronegativity. Greater s character implies greater electronegativity. Okay, so which means that the carbon, which is sp hybridized, is behaving as more electronegative atom as compared to the one which is sp3 hybridized. So more electronegative atom can better accommodate the negative charge as compared to the less electronegative atom, which means that Yellow proton is more acidic because when this proton is removed, the negative charge appears on the carbon that is sp hybridized, and which is more electronegative and can better accommodate the negative charge as compared to the one which is highlighted in in the purple color, where the abstraction of the proton leads to a negative charge on a sp3 hybridized carbon, which is less electronegative and can therefore cannot accommodate the negative charge in a better way as compared to the sp hybridized carbons. So this is how the state of hybridization of the carbon or the species on which the negative charge is present can help us in predicting the stability of the conjugate base of an acid and thereby predicting the acid strength of two acids. Fine. On similar lines, we can compare, like if we have CH2, double bond CH2, and we have this, so ethene and ethyne, which of them would be more acidic if you add a base to them? So based on the similar things, these are sp hybridized carbons, these are sp2 hybridized carbon. So sp hybridized carbon will have more electronegativity and can better accommodate the negative charge after losing the proton. So alkynes are more acidic as compared to alkenes, which in turn are more acidic as compared to alkanes. Let me know if you have any questions related to this. I will get back to you definitely with a satisfactory answer. Thank you.